Good evening, 10th standard. So today, as I told you, I think you would have tried your numericals on your 4th chapter. So let us see some of the numericals. Only very selective numericals I have taken. So this is your 6th numerical. It's not numerical exactly, like they will give a condition and they will ask you to draw a diagram on it. So write your 4th, 5th and 6th lesson will consist of diagrams as well as your numericals. So apart from numericals, you'll also have diagrams. Basically it will consist of a lot of diagrams. So you'd have seen your 6th question. The 6th question goes in this manner. They'll be giving a condition. Okay, it's a given condition where a ray of light is traveling from air medium to water medium. So for you to understand better, I have used different colors. So I have drawn using a blue color, and moreover it's looking black over here. Okay, I have drawn using a blue color to differentiate two different mediums. So this is your first medium, that is air medium, and this is your second medium, which is called as your water medium. So recollect it, air is a rarer medium and water is a denser medium. So when a ray of light passes from it, what will happen? So when a ray of light is moving in this, so the next step you have to draw a normal line. So a normal line I have drawn using a black color. So once it moves from the air medium to water medium, that is from rarer medium to denser medium, it is moving here. What will happen to it? The light will eventually bend towards your normal. Okay, can you see it is bending towards your normal? So I have to draw a line which is closest to my normal. So this is called as your incident ray, this is your refracted ray, and there will be partial reflection. Okay, so it will have both reflection as well as reflection. Okay, this is your so this portion is your refraction. Okay, this portion is refraction and this portion is reflection. So it will have both refraction as well as reflection. So don't get confused in that part. So the next so in this case you will find whenever a ray of light moving from rarer to denser, it will move towards your normal line. Move towards your normal line. Normal line means it is your 90-degree line. Now coming for the next question, I think it is your second question. So in second question, the condition given for us is when a ray of light is moving from water medium to a rarer medium. Moving from water medium to a rarer medium. Water is your denser medium and air is your rarer medium. So once it moves from this medium to another medium, okay, so it's like moving like this in a different angle. Angle is important. So it's moving in a different angle. Now what will happen? From denser to rarer means it will move away from your normal. See, it is moving away. Whereas in this case it is moving towards. In this case it is moving away from your normal. It is moving away from the normal. So I have to draw a line like this. So in this case it is very clear. It is moving from one medium to another medium. Now the next condition is, if at all a ray of light is going to pass through a glass slab. Imagine it is going to pass through a glass slab. How does it will appear? What kind of refraction it will take place? So in this case, you will learn a new concept which is called as your lateral displacement. It is called as your lateral displacement. So I have drawn a diagram here. So before this, I'll explain using your book. Okay, so this is your refraction of light through a rectangular block. So a rectangular block of glass means the first case the ray of light has to pass from air to glass. Can you see? So this will be your air medium. Next one is your glass medium. And the second case, from glass it has to travel to my air medium. So it has traveling totally three mediums in this case. Okay, first is from air to glass, and the next is from glass to air. So there will be two times of refraction. So first let us see, whenever the ray of light is moving from air medium towards your glass medium, that it's going to be denser in this case. So the first ray of light is AO. Okay, the first ray of light is nothing but your AO. The first one is your AO and it is incident on this surface. So now you all know this is your air medium and this one is your water medium. Glass medium. It's glass medium. So now what will happen? Air is your rarer medium and glass is your denser medium. So when a ray of light moves in this case, what should it take place? It should move towards your normal. So for that case, I'm going to draw a normal line. Okay, I'll be drawing a normal line. So again it goes and hits at the next surface, that is your glass medium. So from glass it is moving towards my which area now? Is moving to my air medium. Now here it is your what medium? Rarer medium. So once it comes to rarer medium, it should go away from your normal. So can you see if this is your normal line? So I have to draw a second normal line. Now this ray of light will move in a away direction. So during all this process, if my incident ray is not going to suffer any refraction, it will happen to travel in one straight line. Yes or no? If there is no refraction, it will travel in a straight line. But because of two refraction, what is happening to it? There is a gap between the original path and the deviated path. So this gap or this distance is what we are going to study as your lateral displacement. Okay, we will call this as your lateral displacement here. So I'll again tell you how it works. Listen, you are having a glass block like this. Okay, now a ray of light is incident on this surface. So once when a ray of light incidents, when it's moving from one medium, that is from a rarer medium to denser medium, draw a normal line. Okay, so you have drawn a normal line. So now what will happen? This is your what medium? Air medium, and this is your glass medium. So inside the glass medium, so what should happen to the ray of light? Will it move away or it will move towards? So in this case, it will move towards your normal. So it will be moving towards your normal. So again it will hit at this point. Now again what you do, draw and one more normal line. Now it is moving from denser medium to rarer medium. Yes or no? So now the ray of light is moving from glass to air. So in this case it will move away from your normal. So in this case it will move away from your normal. So that deviation in the path, okay, that deviation in the path of your light is called as your lateral displacement. So that is what I has given as a diagram here. You can see. So if it is going to be in a straight line, this entire pink line is actually going to be the straight, but it has undergone deviation. That deviation is called as your lateral displacement. So in the first case, this is your refraction, incident and refraction. So second one, this is going to be again the incident and this is going to be the emergent ray, the ray which is coming outside your glass. We will call that to be as your emergent, and the displacement between them is called as your lateral displacement. So lateral displacement depends upon the thickness of the glass block, the angle of incidence, and the refractive index of the glass. So therefore also the wavelength of the light used. So always remember, during the entire process, your speed will change, your wavelength will change. The only factor which will never change is your frequency. Okay, whenever a ray of light is moving from glass medium to water or water medium to glass or water to air, anything, your speed and wavelength changes, but your frequency does not change. So note down this particular paragraph, this entire paragraph. Okay, so I want you people to note it down, this entire paragraph. You can study it clearly, make a note of it. Questions will come on that. Based on this topics, we are going to see some of the numericals. Okay, I'm just telling the topic as well as the numerical just attached with it. So the first numerical, they have given the speed of the light, the refractive index, and asking me to find the speed of light in glass. The speed of light in which one? Glass. So I know my formula, refractive index is equal to speed of the light divided by speed of the light in whichever medium you are using. It can be a glass medium, it can be a water medium. So that is one particular formula. So mu is equal to C by V. Mu stands for the refractive index. Mu stands for refractive index. C stands for speed of the light, and V stands for speed of the light in glass. So substitute the values. 1.5 into 3 into 10 power 8 divided by V. So you bring the V this side, and you have to bring 1.5 to the denominator. So once when you cancel, you will get your answer as 2 into 10 power 8 meter per second. So based on that, we'll go for the next numerical, and we'll have one more assumption to be taken here. So refractive index, how do we write a refractive index? Air to glass, glass to air. So you'll get a confusion. You have to write very clearly. So look at here, refractive index of medium 2 with respect to 1. I am going to measure the refractive index of my medium 2 with respect to 1 means you have to write 1 mu 2. So how does the meaning goes? The meaning goes in a reverse way. Refractive index of 2 with respect to 1, and the formula is speed in medium 1 divided by speed in medium 2. You can use that formula, or else instead of speed you can also use wavelength. Instead of speed you can also use wavelength. Now recollect your formula for speed and wavelength. Can you recollect it? What is your speed formula? Speed is equal to wavelength. Wait. Speed of light is equal to wavelength lambda into mu. Okay, this one is speed, this one is wavelength, and this one is your frequency. Just now I told you, whenever a ray of light is moving from one medium to another medium, your speed will change, your wavelength will change, but your frequency will not change. Now my refractive index formula. Refractive index of 1 to 2 means speed of light in first medium divided by speed of light in second medium. Now what is my speed formula? Lambda into mu. So if I substitute lambda 1 into mu divided by lambda 2 into mu. So your mu does not change here. That is, your frequency of the light will never change because your light is moving from one medium to another medium. So in both the cases, your speed will change, your wavelength will change, not your frequency. So in this case, you can also write your formula as refractive index from medium 1 to medium 2 can be written as speed in medium 1 divided by speed in medium 2, which is also equivalent to wavelength in medium 1 divided by wavelength in medium 2. So this formula is also applicable. For that only I have made a box and I have wrote there. Okay. So you can see speed in medium 1 divided by speed in medium 2. Now I am going to write W mu G. W stands for water, mu stands for refractive index, G stands for glass. So it means, what does it mean? You have to read it in a reverse order. Okay, if I am going to read it in this order. Refractive index of glass with respect to water. Refractive index of glass with respect to water. And the formula is speed of W divided by speed of G. Whichever is coming first, put that one as first. Now next formula, look at the next formula. Mu GW, which means again go in a reverse manner. What does it mean? Refractive index of water with respect to glass, and your formula speed of G divided by speed of W. So based on this, look at your fourth sum. So they are asking us, they have given a detail, the refractive index of glass with respect to water. How you have to generally read glass with respect to, go in a reverse manner. Glass with respect to water, it is 3 by 2. Now I have to write my formula. What is my formula? What is the first quantity? Air. So lambda of air, lambda means wavelength, wavelength of air divided by wavelength of glass. Now substitute the formula. 3 by 2 into 5400 angstrom divided by lambda of glass. So once you take the reverse of it, you will get the answer here. I'll write it down again. சவுண்டை குறைச்சி கூட வீடியோ எடுத்துட்டு இருக்கேன்.